Good morning, students. Today we will study the next subtopic of the chapter Current Electricity. After study of Wheatstone network, now we are to study the Wheatstone meter bridge network. The question in the exam will be like this. Explain with net circuit diagram how will you determine the unknown resistance X by using what? Meter bridge. Meter bridge can be written as Wheatstone meter bridge also. Now let us study the construction of Wheatstone meter bridge. I have written principle of the meter bridge. Meter bridge works on the principle of Wheatstone bridge. What is the principle of Wheatstone bridge, students? Principle of Wheatstone bridge is what? When bridge is balanced, the current through the galvanometer is always zero. Same principle we are going to apply over here. So before the working of Wheatstone meter bridge, let us study the construction of Wheatstone meter bridge. Students, we observe here L-shaped copper strip. This particular L-shaped material is made up of copper. One more strip we observe here, which is straight strip. We arrange copper, two L-shaped copper strip and a straight copper strip in such a way that there are two gaps we observe over here. In the first gap, we observe one resistor, unknown resistor, whose value is to be found by using this particular procedure. In the another gap, we observe this symbol stands for what? Known resistance. The value of this particular resistor is going to be known. We will consider any value over here. When I will explain the working, that time I will explain. At that time I will give the idea how we will consider the known value of this particular resistor. Now what we understood till now, there are two L-shaped copper strip and one straight copper strip arranged or connected in such a way that there are two gaps. In one gap there is an unknown resistance we connected, another gap there is a known resistor. This red part represent wire, metal wire. Length of this metal wire is 1 meter. Student, remember, length of this metal wire is what? 1 meter. 1 meter means 100 centimeter. The whole apparatus of this particular L-shaped copper strip, straight copper strip, along with the known resistance and unknown resistance and the metal wire, the whole apparatus connected to what? A battery of EMF E. Battery of EMF E. And plug key K and rheostat RH. The whole circuit diagram is mounted on a wooden box, wooden frame. Let us define the parameters what we have seen in the circuit diagram. AC. What is AC, student? 1 meter long uniform wire. Uniform means the area remains same. There is common thickness, equal thickness of the wire. What is X represent, students? X represents unknown resistance. X represent unknown resistance. What is R represent, student? Known resistance from resistance box. When you will come into the practical lab, I will show you what resistance box. G stands for, one more connection we have to see over here. On this straight copper strip, the connection from point B, it is connected to what? J. J stands for what? Jockey. Jockey means what? We are going to touch that particular component to the wire. Between jockey and this particular wire, galvanometer is what? Connected. What is the use of this galvanometer? When working, I'm going to explain. That time you will understand what is the use of galvanometer. But between point B and the jockey, we connected what? Galvanometer. The student, G stands for what? Galvanometer. T1, T2 and T3 are metal strips. D is null point. What is null point? When I will explain working, that time you will get it. J stands for sliding key, that is called jockey, and here RH, that is what? Rheostat, variable resistor. Students, this is a construction of Wheatstone meter bridge. The theoretical sentences are written. When you explain in the exam, you write down point number 1, point number 2, point number 3 and point number 4. Whatever I explain, you have to write down. Now I will explain the working of Wheatstone meter bridge, because the question is determine the unknown resistance X by using a meter bridge experiment. Student, let us study the working of Wheatstone meter bridge. The circuit diagram is same as the previous one, because here I have to explain the working. Student, when you start the experiment, you have to put a plug key K. When you put plug key K, don't take any resistance from the resistance box. Connect jockey to the point A. When jockey is connected to the point A, galvanometer will show some deflection. That deflection should be extreme left. There is a pointer over here. The deflection in the galvanometer should be extreme left. When I connect jockey to the point C, then galvanometer will show extreme right deflection. When I connect jockey to the point A, the galvanometer will show extreme left deflection, and when jockey is connected to point C, galvanometer will show extreme right deflection. Now students will ask, if it doesn't happen, then what? Then you have to adjust the rheostat in such a way that when I connect jockey to the point A, galvanometer will show extreme left deflection. If it is not showing, you have to adjust the rheostat. When jockey is connected to point C, then the galvanometer will show extreme right deflection. If it is not, then adjust the rheostat. That is your first condition before experiment is going to be start. Once you get extreme left right deflection, then you have to start the experiment. In that experiment, we are going to remove the resistance, because in the resistance box there are different values of resistance: 5 ohm, 10 ohm, 100 ohm, 200 ohm and so on. So you can remove any key from the resistance box, any key, because resistance box is made up of keys, and along with the keys there is a respective value of resistance is mentioned. You remove the one of the key, suppose represent what, 50 ohm resistance. You can take during experiment, I will explain. Remove one of the key which represent what, some known value. Then you have to tap the jockey. This jockey you have to tap on the wire AC. This is a metal wire. Your tap means what? You have to keep like this, tuck, 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 like this. You have to tap the jockey till you will get what? Zero deflection in the galvanometer. You have to tap the jockey till you will get what? Zero deflection. Galvanometer will show the zero deflection. Suppose galvanometer is showing zero deflection at this point D. Then point D is called a null point. Then point D is called a null point. Null point means galvanometer will show zero deflection. Then you have to measure the value, measure the distance, length from point A to D. Let that length be Lx. Then you have to measure the distance between point D and C. Let that length be Lr. Students, since AD is a wire of metal, every metal has some resistance. So Lx wire of length Lx has resistance Rx. Similarly, the length of wire DC, that is what Lr, also has resistance of value Rr. Students, according to the law of resistance, we know that resistance is always directly proportional to length and resistance is inversely proportional to area of the wire. If I merge both the statements, the resistance is what? Directly proportional to length and inversely proportional to area. If I put equal sign, then the resistivity, the concept, the proportionality constant, that proportionality constant is called resistivity, will come across. So similarly for Rr, the value will be what? Rho, that is what resistivity, Lr upon A. Why A is same? Because it's a uniform wire. Student, if you observe, when current to the galvanometer is 0, then will you observe X, R, Rx and Rr form Wheatstone network? I will show you in the circuit diagram. This particular part is what X, this particular branch is what your R, this particular branch is what your Rx, this particular branch is what your Rr. So student, this is what? Wheatstone network, and we know the balance condition of the bridge is what? X upon R, because this is R1, this is R2, this is R3, this is R4, and we know the balance condition R1 upon R2 is equals to R3 upon R4. So student, X upon R is equals to Rx upon Rr. So students, now we will substitute the value of Rx and Rr over here. What is value of Rx, students? Rho Lx upon area, rho Lr upon A. So we observe that this rho get cancelled, A get cancelled. Then what is X upon R, student? What are remaining terms? Lx upon Lr. But what is relation between Lx and Lr? Total length is always 100, because we know Lx plus Lr is what? 100 centimeter. Therefore, what is Lr, student? 100 minus Lx. So I will replace Lr by what? 100 minus Lx. So student, by using this formula, we can find the value of unknown resistance X. Hope so you understood the theory of Wheatstone meter bridge, how to find the unknown resistance. Thank you very much.